Welcome to our channel, where we explore the technologies of the future that will forever change our existence. Today we're talking about something straight out of a science fiction movie: nanobots. Imagine machines so small they can travel through our bodies, repairing cells and curing diseases. Get ready for a journey into the future of medicine. What is a nanobot? Nanobots are microscopic robots, often the size of a cell, designed to perform specific tasks at the molecular level. Built using advanced nanotechnology, these robots can be programmed to carry out a variety of functions within the human body. Imagine millions of these tiny workers navigating through your bloodstream, each with a specific task, like repairing damaged cells, removing viruses, or delivering drugs precisely where they are needed. These nanobots are made from biocompatible materials to prevent the body from recognizing them as intruders. They have a complex structure, sensors to detect their surroundings, actuators to perform mechanical tasks, and miniature power sources to fuel their operations. Some can even self-assemble and self-repair, making them extremely versatile and resilient. How nanobots work. Once inside the body, nanobots use a combination of chemical and magnetic signals to orient themselves and reach target areas. Imagine a journey through your bloodstream. Nanobots travel propelled by the natural movement of blood, continuously analyzing their surroundings with their advanced sensors. When they detect a damaged or infected cell, they can attach to it and begin the repair process. Nanobots can operate autonomously thanks to sophisticated artificial intelligence algorithms. These algorithms enable them to make quick decisions based on the information gathered by their sensors. For example, a nanobot designed to combat cancer can identify specific tumor cells, inject a drug directly into the cell's nucleus, and then monitor the treatment's effectiveness. Precision is key. While traditional treatments like chemotherapy attack both healthy and diseased cells, nanobots can target only the diseased cells, drastically reducing side effects. Additionally, they can be programmed to release drugs only in the presence of specific conditions, ensuring controlled and targeted delivery. Current and future applications. The applications of nanobots are nearly limitless. Currently, researchers are experimenting with nanobots for drug delivery, tissue repair, and even cellular-level surgery. Imagine a world where invasive surgical operations are replaced by nanobots that repair tissues from within, without the need for incisions or anesthesia. In the near future, we might see nanobots used to treat genetic diseases by correcting errors in DNA, or to regenerate damaged organs without the need for transplants. They could also be employed to continuously monitor our health, detecting and treating diseases in their early stages before symptoms appear. Another fascinating application is the potential to enhance human capabilities. Nanobots could boost our immune system, improve cognitive abilities, or even increase our strength and endurance. We're talking about a future where the biological limits of the human body can be surpassed through nanotechnology. A journey into the future. Although nanobots are a technology of the future, we are already taking the first steps towards their realization. But how will these tiny robots actually be administered into our bodies? Scientists predict that nanobots could be injected directly into the bloodstream via an injection or ingested in the form of capsules. Once inside the body, they could be guided by external magnetic fields or programmed to autonomously navigate to target areas. But how long will we have to wait before we see nanobots in action? Despite the rapid advances in nanotechnology, it is likely to be several decades, if not 100 years, before these robots become a common reality in medicine. The complexity of their design and the need for rigorous clinical testing to ensure safety and efficacy make their development a long and arduous process. Moreover, there are many challenges to overcome, from the miniaturization of electronic components to the creation of biocompatible materials, to solving issues related to power and the longevity of miniature power sources. And let's not forget the regulatory and ethical issues that will need to be addressed before nanobots can be used on a large scale. Current challenges in nanotechnology. Despite promising advancements, today's science faces numerous hurdles before nanobots can become a practical and widespread reality. Technical, biological, and regulatory challenges are significant and require innovative and complex solutions. The first major hurdle is the miniaturization of electronic components. Creating robots small enough to be invisible to the naked eye, but powerful enough to perform complex functions, is an unprecedented engineering challenge. Current electronic components need to be reduced by several orders of magnitude while maintaining functionality and reliability. For instance, motors, batteries, and control systems must be miniaturized to fit the nanoscale without losing effectiveness. Additionally, the need for an efficient and long-lasting power source remains unresolved. Current batteries are too large and inefficient for use in nanobots. Another critical challenge is the biocompatibility of nanobots. The human body has a highly efficient immune system that can recognize and attack foreign particles, including nanobots. Designing materials that are not only compatible with the human body but also capable of avoiding an immune response is crucial. Nanobots must operate without causing inflammation or adverse reactions, and their removal or biodegradability must be ensured to avoid harmful accumulation in the body. Finally, regulatory and ethical issues represent a significant hurdle. Currently, there are no specific regulations for the use of nanobots in the human body, and regulatory agencies will need to develop new standards for the safety and efficacy of these technologies. This process could take years of research and clinical trials. Not all that glitters is gold. But with great power comes great responsibility. The use of nanobots raises ethical questions and safety concerns. What would happen if these microscopic robots were hacked or manipulated? The potential for external control over our bodies is frightening. In a world where nanobots can enter our bodies without us noticing, privacy and personal autonomy become crucial issues. Imagine scenarios where nanobots are used for malicious purposes, such as sabotaging the health of individuals or groups, or the possibility of internal surveillance, where every move and health condition is monitored without our consent. These are risks we must seriously consider as we venture into this new technological era. The future of nanobots is fascinating and full of promises, but also dangers. It's crucial that as we develop these incredible technologies, we don't forget to consider the ethical and safety implications. We must ask ourselves, are we ready for a world where technology can intervene so intimately in our biology? Thank you for watching. If you enjoyed this video, please like, subscribe to the channel, and turn on notifications so you don't miss our future content on the technologies of tomorrow. And remember, the future is closer than you think.